A card is presented, and the terminal beeps. Between those two things, something decided whether that charge was fraud. There's no queue to join, no analyst to escalate to, no option to say we will look into it, approve or decline right now with whatever you know at that instant. That deadline is the entire reason fraud detection is an architecture problem rather than a machine learning problem. So let's design the system around the constraint that actually binds it, and see why the most common design is not slightly late, but structurally too late. The design most companies start with is the one their data warehouse already suggests. Write every transaction to a database, then run a job over it. Overnight at first, then hourly when someone complains, then every 15 minutes when someone complains louder. Each step feels like progress, and none of them addresses the problem, because the problem is not how often the job runs. The problem is the order of operations. The money moves at the moment of authorization. Any design that stores the event first and evaluates it afterwards has already let the decision point pass. You are no longer detecting fraud. You are compiling a very accurate list of fraud that already happened, which is useful for a chargeback team and useless to the person holding the card. Making that job run every minute does not fix it. It just makes you wrong more frequently. The flip is to stop moving events to the question and start moving the question to the events. In the batch world, the query is the active thing. It wakes up, scans a pile of stored rows, and produces an answer. In a streaming world, the query is always running, and the events flow through it. Nothing is scanned because nothing was ever put down. A transaction arrives, passes through the logic that is already live and already holding everything it needs to know, and a score comes out the other side while the terminal is still waiting. That is the whole idea, and it sounds almost too simple. The consequence is not simple at all, because a query that is always running has to keep its working memory somewhere. In the batch design, the history lived in the database, and you reread it every run. Here, the history has to live inside the running computation. Here is what makes this hard, and it is not the model. The signals that catch fraud are almost never properties of the single transaction in front of you. The amount is normal. The merchant is normal. What is not normal is that this card was used in 2 countries an hour apart, or that this merchant has taken 40 attempts in a minute from cards that have nothing else in common. Every one of those is an aggregate over recent history, and looking history up at decision time is exactly the lookup you cannot afford. So you do not look it up, you keep it. The stream processor holds a running aggregate for every card and every merchant, updated as each event passes, so the answer is already computed before the question is asked. That is what keyed state means in practice. And it introduces the messy part. Events do not arrive in the order they happened. A transaction from a terminal with poor connectivity can turn up seconds late, after you have already scored the one that followed it, which is why these systems distinguish when something happened from when you found out. The finished shape is a path, not a pile. The authorization is published to a log the moment it happens. That log is partitioned by card, so every event for one card lands on the same worker and its history is local rather than remote. The worker updates its aggregates, applies the rules and the model, and returns a score inside the window. And the same stream keeps flowing into storage afterwards, because you still want the warehouse, the reports, and the training data. What changed is that storage is no longer on the critical path of the decision. It is a consumer of the stream, not a step in it. Everything hard about this design lives in that state. How long you keep it, how you window it, what happens when a worker dies holding it, and what you do with an event that arrives after you already decided. The real-time fraud Detection series builds the whole pipeline properly, one piece at a time. That is where to go next